Okay, in this video we are going to see the same problem which was already discussed in the previous video, which was a lead code problem number 42. This 42 problem is trapping the rainwater. When I say trapping the rainwater, we have the set of walls, and if the rainwater is coming on top of these walls, how much amount of the water it is uh, these walls are holding. So if I drop the water, it will be slipping here. If I drop the water from the top, this is the position where I am holding the water. Can I hold the water here? No, it will flow down, right? So this is the amount of the water I can hold if the rainwater comes on top of these walls. But the last approach was an brute force approach, because every time we are going to find max on the right side and max on the left side. So it is going to be an square complexity. But in this video, we are going to see an optimized solution where I'm going to iterate the array, the length of the wall only once. When I say once, that means the complexity would be order of n, since I am iterating only once. N is the number of walls. Here it is 4, so it is going to be order of 4. Now for this approach, we are going to take a two pointer approach. When I say two pointers, the name of the pointer will be left and right. Most important thing is, when we use two pointers, these pointers can be attached on very first data, or it can be attached on the last data, or left pointer will be attaching on the left side, right pointer will be attaching on right side. This is one strategy. And the second thing is, which pointer we are going to move on what conditions. So these two things are very important when you are considering two pointers. Now in this one, we are going to attach left pointer here and right pointer here. Okay, and in the same way we are going to maintain left max and right max, but there is a big difference. Let me demonstrate with a dry run. So we have the pointer left, we have the pointer right, and I have the max of left, max of right, and I have the amount of water. So let me create a table on this one. Now with this data, I'm going to iterate. Very first thing is, what will be the initial value left, since I'm pointing to the very first element. So the index position, let me write the index position in different color. This is my 0 index, 1 index, 2 index, 3 index. These all are index of array data. What is the initial value? The initial value of left will be 0, since I am pointing to the very first wall, and right pointer attaching on the last wall, so it is going to be length of the array minus 1. So if we consider length of the array, this data, it is 1, 2, 3 and 4. That's the reason the right pointer will be length of array minus 1. So what will be that? It will be 3. So this is my initial value of left pointer and right pointer. Since I am just starting iteration, so I will consider, I don't know what is the max length on the left side and right side. So I will be considering initial value of max of left is 0, max of right is 0. Now, how much amount of the water so far? Initialize with 0. As and when I am getting result, I keep on adding that into this water result. Now, very first thing, check for which one is minimum out of left and right. Based on that, I am going to move the pointer. So left height was 3, right height was 2. Which one is lesser? The right one. Right pointer is lesser, so I'm going to move right pointer. So very first formula is which wall is having lesser height, move that pointer. This is very first formula. Okay, since comparing with this one, this height is lesser. Now this is going to be lesser, so I'm going to move the right pointer. From 3 I'm going to decrease to 2. So very first thing is I'm going to move, but before moving to that pointer, there is one more conditions. With this right height, okay, right height which is a lesser, now compare with max value of right. If this wall length is somewhat bigger than whatever the max value of the right, since I'm considering right, because the left was higher, so ignore this one. Now we consider only right. This right height, if it is more than the max of the right, then replace this with this one. If it is greater or equal, since this height is greater, so I'm going to replace this height. So what all the values we are going to change, instead of r max 0, it is going to change to 2, because the right max was having a greater. That indicates that yes, I got a bigger height, that's why I am replacing right max. This is one thing. Okay, since we consider only right max, so I'm going to move the right pointer. So right pointer is going to change from 3 to rest of the values I will write in the same color, since we are not change anything. Did we got any water? No, so far it is, again it is going to be 0, because since we consider only one wall. Now we move to this one. Okay, now with this 0 and 2, we are going to iterate. Okay, now right pointer is moved to now 1, sorry, the index is 2. Now with this index, this is my right, still the left was on the same position, 0 index. Which one is lesser? Height of the wall, again it is a right wall, so this right wall. Now compare with max of right. What was the max on the right side? It was 2. Okay, comparing with these two, since I was holding the max length was 2 on the right side, right now I'm on this wall. Is it lesser or greater compared with the max on a right side? Yes, it was lesser. Lesser means that indicates that I can hold water on this difference, the difference of right max and the wall length, which is I am here. I will repeat one more time. Okay, first we need the right pointer is on this wall, left pointer is on this wall. Now our max was holding 2. Can you see here? Now since the lesser wall I am going to consider, compare with r max. Is it lesser or greater? If it is lesser, yes, I was having a max length on the right side. That means I can hold the water, the difference, which is r max minus r. So how much amount of the water I can hold? 2 minus, what is the length of this one? 1. So I will be holding 1 unit of water here. So since I am going to change the values, so I will be changing with a different color. Now 1. Now this was the right pointers. So since we operate on the right, I am moving the right pointer. So what all the changes? The right pointer again, it changes from 2 to 1. The water amount we got is 1 unit of the water here, and rest of the element remains same. Left is still 0, left max is still 0, r max is 2. Okay, now where we are right now, the first right pointer is on index 1, left pointer is on index 0. This is left, this is right. Which one is lesser? Okay, that only we have to consider. This is lesser, the right is lesser again. Now with this one, this right I am taking, and with the right max, this was right which is lesser. So right and right max, what is right max? Right max is 2. Now this, is it lesser or equal? If it is lesser, then I can hold the water. Since both are same, r and r max was having both the wall length 2. That means I can't hold any water on top of this one. That's why the amount will be 0, 0. So it remains same 1. Since we operate on which wall? The lesser, which is right wall, the right value will be decreased to again 0. Now what was the old value of the left? It was 0. Max on the left was 0. Right max was 2. So the amount was added is 0 plus 0. It is here, it was plus 1. So it will remains 1. Now currently where we are, the left pointer is 0, right pointer is 0. That means yes, we are done. So till what condition I should repeat this loop is left should be lesser than right. Now since both are same, terminate the loop. Left pointer should not cross to the right pointer. This is one condition. Since we are moving the left plus plus, right minus minus till it reaches to one point, yes, stop that. Don't move beyond the boundary of right and left. So the final solution is this one. The two formulas. Left pointer pointing to 0 index, right pointer pointing to the last index. Consider the wall which is lesser length and move that pointer before moving that. Okay, this is lesser, compare with max so far on the right side. So far, yes, it was 0 initially. This was higher. If it is higher, replace that. Okay, since I got a good height on the right side, so I am replacing with 2. Same will be repeated on left. In case left I got a bigger height, replacing the left max. That's the reason I replace max. Now if I get any height which is a lesser, then the max, r max, since this is right pointer wall, that indicates that I was having a bigger height wall on the right side, and the current height of the right wall is lesser, so I can hold the difference as amount of the water. That's the reason I added as 1. Rest of the time, no, I'm not getting. This is 2, the max was 2, so I will not be holding any water. And we have not moved the left pointer because I never get a right pointer which is greater than the left pointer. If it was, then I will be moving. This is how we can do in one pass. That means only an iteration we can find the solutions. Let's move on the implementation perspective. Okay, when I say implementation, this is the condition I was talking. So left should be on the left side, right should be on a right side. If both are going to point on a single index, at the end we reach to 0 and 0 index, that's the reason we stop the loop. This is first thing. Okay, and what was the initial values? The initial values was, we consider left pointer, right pointer, left max, right max, and the amount of water. This was initialized with 0, and this is what length of the array minus 1, which is 4 element, means it was 0, and the left max value will be 0 and right max is 0. See, and the amount of water is 0, and we started navigating, iterating all the loops till left is left, right is right. If anyone is colliding each other, stop the loop. The very first thing we are considering only the one which is lesser, right? Left, is it lesser than right? Which one is lesser? Okay, so that only we are considering. Since the very first operation the right was lesser, so we reach here. Okay, and compare with the height. If I got a new height of the wall, yes, I'm going to replace a right max. Only in this condition, if I am getting anything which is higher length, replace right max. In this case, yes, left was a lesser values, then I'm going to move which pointer? Left pointer. In this case, right was lesser, so I'm going to decrease the left pointer. So whichever is lesser height, move that pointer. I hope you got this one. This is lesser, left moving, right is lesser, right is moving. Now out of this one, let's consider, in our case, right was lesser and I reach a new height, that's why I am replacing right max. It was changed to 2. Otherwise, in the second iteration, what we got was a lesser height, which is this one, compared to R max, which was 2. So the difference amount of the water, it will be holding the water. That's the reason, if in this case, if it is right max is higher, then right max minus height of the wall, which is 2 minus 1. So this is the amount of the water I am holding. So water will be 0 plus 1, and we are moving right pointer. So keep on moving the right pointers. This is how we can do water tapping in single iterations.